Target downside deviation. Let's start off our discussion with standard deviation. The issue with standard deviation is that it looks at the dispersion of returns around their mean. But in reality, the direction of that deviation, whether that deviation is above the mean or below the mean, will affect the investor's utility differently. For example, suppose that the standard deviation is 15%. So this would mean that on average, individual returns deviated by plus or minus 15% from the mean return. However, for most investors, the increase in utility from a 15% gain is less than the utility or the emotional reaction to a 15% loss. And that's what utility is. Utility, think of it as satisfaction or the emotional reaction you get from an event. So you can see that in both cases, the number is 15, which matches with the standard deviation of 15. But the investor's reaction to a loss is much greater than the investor's reaction to an equal gain. And study after study has shown that to be true. And one way you can think about it is, over the long term, investors have gotten used to positive return, because over the long term, it's true, stocks do yield a positive return. So a positive return sort of becomes like the norm. So when we experience a loss, that triggers a much greater emotional reaction. And this is where target semi-deviation comes in, or downside deviation, because it focuses on returns that fall below a certain threshold. So ladies and gentlemen, the big picture is as follows. Standard deviation is symmetric. It says the deviation is plus or minus 15%. But target semi-deviation says, well, this 15% is not the same as that 15%. So since investors get a greater emotional impulse or reaction from a loss, maybe we should just look at risk on the downside rather than just looking dispersion on the upside and downside. So let's have a look at an example. Suppose that the lowest acceptable level of return is 3%. So you can pick any threshold in order to calculate the target semi-deviation. So the other way you can interpret the 3% is that it's the target. It's the target return below which we don't want to see our portfolio returns fall under. And let's just suppose that we're looking at data over the last 5 years, and here are the return figures over the last 5 years. And the way we calculate deviation is as follows. If you are above the target, then you don't count. Why is that? Because target semi-deviation only focuses in on returns that fall below. So we're not interested in the data points that lie above the target. We're only interested in the data points that lie below the target. So if we look at the first return, it was 7%. Now 7% was above 3%, so you could see it doesn't register as an observation for target semi-deviation. And there it is, upside volatility does not count. How about the second observation? We had a return of 2. Well, 2 is less than 3, so it was a minus 1% deviation below target. So this would register in our data set. Year 3, the return was 5%. This was above, so you could see it doesn't register. And year 4 is minus 1. Well, that is definitely below 3. How much lower than 3? Minus 4. So the way to look at it is negative 1% return is minus 4% below the target. And then finally, in year 5, we had a return of 8%. And since this is above the target, it doesn't count, so it's just 0. So once we've done that filtering process, in other words, We're just looking at the downside deviations. The next steps would be as follows. So here it is. So step 1. This is the framework for calculating target semi-deviation. The process is almost exactly identical to calculating just variance. In other words, we look at the sum of the squares of the deviations and divide it by n minus 1. The only difference is, with standard deviation, you look at the deviations of all the observations. But with target, we will only be looking at the downside deviations. So here's what you got. So here's all these numbers, and I state them right there. And then you find their square. So you can see the only numbers that are registering are the observations that fell below our target, because 0 squared is just 0, so it doesn't count for anything. Now the denominator for target semi-deviation is the same as just ordinary standard deviation. It's just going to be n minus 1, which in this case is 5 minus 1. So then we get 4.25, but remember that's just the squared version. And then once we have that variance information, we just find the square root, so that we get 2.06. So this would be our answer for target semi-deviation. So this represents how dispersed the data was below the target. Now, notes. If we pick a high target return, what would happen? So if instead of 3, we pick, let's say, positive 30%. Well, if you did that, ladies and gentlemen, all these numbers would fall below the target, and therefore all these numbers would be greater than 0, and as a result, target semi-deviation would be higher. So there would be more returns that would fall below the target, and therefore the dispersion would be higher. Because here's the logic. Even if you don't follow the math, let's see if we can follow the logic. If your target return is very high, then there's going to be a lot of returns that fall below that target. So you're going to get a lot of volatility below that target. On the other hand, if you pick a very low target return, so in our case, if we picked let's say a number of, if we said a target was actually minus 10, well, you can see all these numbers are above 10, and therefore none of them would register, right? Because remember, with target semi-deviation, we're only interested in returns below the target. So if your target is minus 10, none of these numbers are below the target, so none of them would register in the computation. So you would have absolutely no volatility below the target, because I have absolutely no observations below the target. And that's exactly the point that we make here. So if you pick a very low target, there'll be less returns that would be below it, and therefore the target semi-deviation would be much lower.